having more fun than we can possibly tolerate. Okay, multiplying and dividing rational expressions. Um, Section 11.4, whoops, 11-4, page 698. Okay, so when you multiply fractions, okay, a rational expression again has a polynomial in the numerator and the denominator, and when you multiply fractions, all right, you have a fraction a over b, and you have a separate fraction c over d. When you multiply them, you simply multiply the numerator, and you separately multiply the terms in the denominator. So this becomes AC divided by BD. No big whoop. We're going to do the same thing with rational expressions. So here we go, Wilbur. Wilburine, we have r squared times x all over 9t cubed. R squared x all over 9t cubed. That's one fraction. The other fraction is 3t to the fourth times, or divided by r. So let's multiply anything we can. Let's multiply the numerators, and then we're going to simplify. Let's multiply the numerator, multiply the denominators. Okay, so let me see, this can be 3. We usually write the coefficient first. So 3 and r squared x t to the fourth. Okay, 3 r squared x t to the fourth. Hey, konnichiwa. And down here, we're going to have, it doesn't matter what order you write these things. I'm going to write it in the same order I have over here. So this is going to be 9. Let's just write it down. So 9 times r times t cubed. Now, let's write these things in terms of greatest, the GCF, right? The common factors. And brain just went blank there for a second. So this can be 3r squared x. This is going to be t. Oh, hold on. Hold the phone again, Wilbur. All right. Whoa, dude. This is going to be 3. I have an r down here, so I'm going to do r times r, all right, times x. Why did I do that, r times r? Because this is an r that's going to cancel with one of these r's. So 3r times r, x, and this is going to be, I'm going to write that as t cubed times t. Does that make sense? I hope. This is 9 is 3 times 3. Why am I doing that? Because I got a 3 up here. So now I've got a 3 times 3, so I got a 3 down here. Those are going to be able to cancel. One of those is going to be able to cancel down here. I've got my r. I've got my t cubed. Oh, yes, I do. He's got a t cubed. Oh, you envious? Not for long. So I've got a 3 that in the numerator and a 3 in the denominator. They cancel. Hasta luego. All right, I have an r. It doesn't matter which one. I cancel with this r. All right, I have an r here and an r down there. As long as you have an r up here. Again, these are all multiplied. We couldn't do this if they were plus or minus, but we can with multiplication. So r divided by r cancels. X has nothing in the denominator to cancel with. But I have a t cubed up here and a t cubed down there. Those cancel. And now let's just write out whatever's left. And we have r, x, and t. R, x, t, all over 3. And we can't do anything else with that. So let's do another one. This is going to be example B. Example B, 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 example B. Oh, times, so that's 8 plus 4 over a squared times a divided by a squared plus 2a minus 8. So a squared plus 2a minus 8. Okay, okie dokie. Let's see what we can do here. This is factorable. All right, we can factor it. So I'm going to leave this one. We can get rid of the times sign too, right? That's going to be a plus 4. I'm going to put a parentheses here times a divided by a squared times all of that. But I'm just going to save us a step and factor this. This is going to be positive 2. Let's see, that's going to factor into plus 2 and plus 4 and minus 2. All right? Positive 4 times negative 2 is negative 8. So this is going to factor into a plus 4, which is convenient, a minus 2. Let me again just point out what I just did here. I looked at that, and I just kind of did it in my head. I needed to know what are the factors of negative 8 that are going to give me plus 2. Well, the factors of negative 8, 4 times negative 2, when those added together are going to give me positive 2. So my other factor, of course, I could have done negative 4 and positive 2, but that wouldn't have given me a plus 2a. So anyhow, that works out. So we did that, and here's our common factor in the numerator and denominator. Okay. So now we end up, the other thing we have, I just noticed this. Remember that's an a, and this is a squared, which is a times a. That was a squared, and that's a times a. And the reason why I didn't catch that at first, but that a cancels with that a. All right. We have the same in the numerator and denominator. So now there's nothing in the top here, which means it's left with the number 1. And we write what we have in the denominator, which is a minus 2. Or you could write that as a squared minus 2a, 1 over a squared minus 2a. This is easier in terms of finding excluded values. If they said, okay, now, Frederica, find the excluded values. What are the values that a can't be? You'd set this to equal to 0. So a equal to 0, you can't. If you put 0 here, it makes the denominator 0, bad. If you put a minus 2 equal to 0, so a equals 2. So if you put 2 in for a, that's also bad. So the excluded values here are 0 and 2. All right, what about dividing? Well, thank you for asking. That was multiplying. And we're going to do the same thing, just remembering your rule for dividing fractions, where you flip the second fraction over and you multiply. So, hi. Here, I'm going to pause for a second.